For decades, computing required a heavy upfront capital expenditure. You purchased a physical machine, and the moment you took it out of the box, the components began depreciating and moving steadily towards obsolescence. A virtual cloud PC bypasses that cycle. The actual computer, the processor, the memory, and the storage drive, runs entirely on a remote server inside a highly secured data center. Your physical device is demoted to a simple conduit. Its only responsibility is to display the live video feed of that remote desktop and send your keystrokes and mouse movements back across the internet. The plastic and metal sitting on your desk is no longer the computer. The internet infrastructure itself does the processing. Offloading the processing power to a data center unlocks instant hardware scalability. You can upgrade memory or storage with a click, completely removing the cost of replacing aging hardware every 3 to 5 years. That convenience requires a strict technical baseline. Tricking the human brain into feeling zero input delay requires a highly stable connection, running between 15 and 50 megabits per second, with round-trip latency staying under 40 milliseconds. If that connection drops, the computer effectively ceases to exist. You are entirely dependent on your network. If you can meet those network requirements, the next step is evaluating the providers. Cloud PC is a broad delivery method, and the actual service you buy looks completely different depending on whether you manage a global corporation, code complex software, or play video games. Making the right choice requires matching the precise financial and technical structure of a service directly to your daily workflow. For corporate IT departments, managing thousands of physical laptops scattered across the globe is a logistical liability. Every localized hard drive represents a point of failure that must be tracked, secured, and updated manually. Cloud architecture replaces those heavy laptops with lightweight endpoints, like the Microsoft Windows 365 Link. This device is stripped of all local storage and processing power. Its only function is to connect to the internet. Because there is zero local storage, physical data theft is neutralized. If someone steals the device, they acquire an inert piece of plastic. There are no corporate files or cached emails to compromise. This centralization also solves the nightmare of unpatched software vulnerabilities. IT teams can apply a critical security patch to the master virtual image in the data center overnight. By the next morning, the entire remote workforce logs into a fully immunized system. This matrix highlights deployment options. Left, Windows 365 offers a predictable, flat-rate subscription that anyone can deploy. Right, Azure Virtual Desktop provides deep technical control, but requires dedicated DevOps engineers to navigate complex network routing and load balancing. Enterprise leaders have to decide if giving up granular local control and paying a permanent monthly operational fee is worth the benefit of automated security and centralized device management. Software developers face a different set of hardware constraints. Compiling heavy code bases and running automated tests requires intense, highly variable computing power. Platforms like Microsoft DevBox address this by letting teams spin up pre-configured coding environments in minutes. They use a capped hourly pricing structure, which gives developers massive processing power for a specific task without blowing out the monthly budget. That need for power peaks in artificial intelligence. Training complex machine learning models requires enterprise-grade hardware, like the NVIDIA H100 GPU, which costs tens of thousands of dollars to purchase physically. Instead of buying that hardware, AI researchers are increasingly renting fractional supercomputing power by the hour. This chart tracks the cost of renting an H100 GPU across platforms. Premium hyperscalers like Google Cloud charge around $11 an hour. Decentralized networks like Thunder Compute and Spheron drive that price down to roughly $1.38 an hour. The trade-off for independent developers is straightforward. Securing those ultra-low hourly rates means you have to build your own environments, sacrificing the highly integrated managed machine learning tools provided by the premium vendors. By trading compute power as a liquid, on-demand resource, solo researchers on strict budgets can access the exact same hardware used by massive tech conglomerates. In the consumer sector, users are leveraging the cloud to avoid spending $2,000 on custom gaming hardware. Many opt for the library-based model, like NVIDIA GeForce Now. It offers highly polished, affordable access to high-end graphics through a simple monthly subscription. But that affordability comes with strict borders. You do not own the underlying Windows operating system. You cannot install custom game modifications, and you are entirely restricted to a pre-approved list of publisher titles. To bypass those limits, players use platforms like Shadow PC or Air GPU. These are true cloud PCs. They hand you total administrative control over a remote Windows desktop, letting you install any launcher or modification you want. This graph maps the financial reality. Pay-as-you-go services start cheap, but costs spike as playtime increases. Flat-rate subscriptions start higher, breaking even for heavy users. Hourly platforms also carry a hidden cost, an ongoing storage fee to save games, pushing that hourly line higher. For gamers, achieving absolute software freedom requires calculating your exact monthly playtime, pinpointing the break-even point between a casual hourly rental and a heavy-use subscription. The virtual cloud PC has matured past early experimentation. For demanding digital workflows, it is an active economic reality. This decision tree maps the optimal path. Unreliable internet or strict data privacy dictates buying local hardware. For enterprises, desktop as a service instantly eradicates network vulnerabilities. For AI researchers, renting hourly computing provides flexibility without hardware debt. For heavy gamers, flat-rate subscriptions provide custom rig power affordably. The localized box under the desk is increasingly unnecessary. The decision now is simply determining the most efficient way to stream on-demand power directly from the data center to your screen.